Okay, we've talked a little bit about this week's lab. I want to go just a little bit more in depth with it here. And so we're using the Node MCU, and if this, I've got an example of some software on your Node MCU. This one's supposed to attach to my hotspot, but whether I'm getting any cellular connection in here, and use that for my the Wi-Fi connection, and then it's streaming radio off a Florida classic rock radio station, and so it should be spitting some sound out here, but I don't think I'm getting some good connection on my hotspot. But I'll bring it up into lab and let you listen. So it's just a sample code. One of the things that you could do from just that, just on your ESP8266, is put your LCD screen, your SPI LCD screen in it, and be able to select different channels. And it's got a little 8-pin 5-watt amplifier on it as well. Anyway, so whether that makes some sound or not, I don't know. But we're using the Node MCU as a standalone. So we used it as a coprocessor. And by doing this, we're programming it directly in. And that means your AT firmware is not going to be being used. It says add the PubSub client. Now you'll notice the PubSub client here is by Nick O'Leary. If you go searching on PubSub, first thing you do is you go in the Node MCU and you set it up, the Arduino interface, so that it has the ESP8266 firmware, which downloads the whole development tools for it. And then for the libraries, you go on search for PubSub. And like I say, there's 5 or 6 or more different versions of the publish subscribe clients, and others I'm sure work. The ones that I am showing you with the example code I'm showing you works with Nick O'Leary's. And when you go and select one of these libraries, it will download that and the associated examples that come with it. And so, like I say, if there's not something that's quite working for you, there might be another library that has other examples that might work better for what you want. And so you can go look at that. I find especially, I've noticed with different OLED displays or different TFT displays or different temperature sensors, the DHT11s or 22s you might have from your Kuman kits, there are several different libraries, and some work better than others. And so you open the library, manage libraries, find the PubSub client, and again, that's after you've got the MQ, the ESP8266 set up as the board. And then if I'm going in here and looking, once I have the file preferences and I have the board selected, and again, you just search ESP8266 Arduino, and it will show you how to have the board manager to be able to go and install that. So once you do that, then when it finishes loading under examples, you'll see all these. There's all the standard libraries, and then you'll see coming down here a whole bunch of libraries that says examples for Node MCU 1.0. That's our board. If you go look at the different boards, there's a ton of different boards for ESP8266s, and it has different I/O pinned out and things like that, but that's our board. And so it's showing you all of these different examples just for an ESP8266. There's a specific ESP8266 Blink. There's all sorts of other things. If you want to just have Wi-Fi, you want to scan the Wi-Fi networks, there's examples for all of that, sending UDP, all of that. Then when I went to do PubSub, it says examples from custom libraries, and it puts the PubSub example libraries from Nick O'Leary's package in there. And so the lab, I think, says you look at the MQTT ESP8266 library, and I think we've got it open here. And so there's MQTT ESP8266. And so if I go back to my lab, so we went and got the library, open up the MQT ESP8266, and then it says change the SSID and password, and of course we're bakery204 and that great long password there. And the server it's going to is the broker.mqtt-dashboard.com, which is the HiveMQ broker that we looked at last time. There are other public brokers, and sometimes I've had in lab where that hasn't worked. Eclipse Foundation has some brokers up there, but there's a few different public ones around. Since last year, MQTT, the HiveMQ people give you an ability to have a personal account for up to 100 devices with no charge. So you could get it off kind of the public and have your own account, and so make it a little bit more safe to use. From your sample software, I want you to change the topics that the example code comes with, and I want you to change in topic and out topic to be ESET 260 slash in mel in my case, and ESET 260 out mel in my case. So then if you go and take a picture of it, I can see it's going to your topic, and then compile and run it. And then when we looked a little bit last time at HiveMQ, and if you just go and search that, that's showing you in general what's going on at the HiveMQ MQTT broker, being able to handle different messages. And here it shows that there was 1,600 subscriptions, and the it had 173 at the time I did this retained messages. And again, if I publish something, I can tell it that I want to publish. And if you don't have, if a subscriber for that topic isn't there, keep the last message or keep some messages, and you have a bunch of MQTT options to do that. In here, this is accessed through this MQTT WebSocket client. And so the default MQTT port is 1883. And so it's sitting, so my device is going to talk to port 1883. There is a WebSocket web page interface to that broker, and its web page is at 8,000. And you access it from clicking on this for a WebSocket client, and it will go and connect up at 8,000 to this web page. Okay, and so that's the web page is port 80. It's connecting to the broker at 8,000. Your MQTT devices are connecting at port 1883. And so what we're going to do is my web interface is going to publish and subscribe to that broker, the HiveMQ broker, and the ESP8266 device is going to publish and subscribe. And the nice thing about MQTT is we don't have to know anything more than I'm publishing to a topic and I'm subscribing to a topic, and I don't care what the other thing is on the other end. So I could have just a sensor and publish to a certain topic, go back to sleep, take as little battery life as possible. Every 10 minutes, wake up, grab a temperature, humidity, and then go back to sleep. And so I can do that kind of thing. And then as far as my subscribing end, or maybe my desktop end, or what have you, I could have a Node-RED interface that has a bunch of graphs and charts and all the rest. And every time the broker gets a publication from an end device, because I subscribe to those same topics, it forwards them on to me. And so then I can chart the different things when they come online. Okay. And so it's very nice that way, and the broker handles the complexities, and I can have a ESP8266 with just a screen and nothing else, and it's just subscribing to one thing, or I can have a whole desktop application or what have you. Okay, so HiveMQ, this WebSocket client, when I go connect, it will random pickup. You see it's at port 8,000 here, and it's got a client ID. It randomly kind of picks a client ID, and I connect up, and it doesn't matter who's connecting and who's not connecting. On the software end of it, it's a random ID that I'm connecting up as well, because I'm not worried about who the individuals are. I'm more looking at what the topics are. And again, you're going to connect, and then you're going to subscribe to, ESET 260 out your name, for instance. And then when your device publishes to the broker at that topic, it looks for the list of subscribers and goes and forwards it on. Okay, so that's kind of how all of that goes. And it says, click and subscribe to ESET 260 out your first name. And then over on here, we'll see by default what it's going to do. It goes to in topic and out topic by default right now. You need to change that to whatever you're subscribing to. My software here, I put a little slash. I need to get another picture because I told you to do it without the slash. Those matter, okay? If you put slash ESET 260 and your other isn't a slash, it's got to match. Okay? Otherwise, you just don't get anything, okay? And so that shouldn't have one there. Over here on topic here, it should be ESET 260 slash, for instance, in my case, InMel. Anything I send on the message will go to the broker, and as long as my ESP8266 is subscribed to that, then it will forward it to that location. Okay, and then so I should be able to get a back and forth with that. I want to look at just kind of a little bit on the actual example, and it says basic ESP8266 MQTT example. This sketch demonstrates the capabilities of the PubSub library in combination with the ESP8266. It connects to an MQTT server. It publishes hello world to the topic out topic. So if I don't do anything first and I have out topic and in topic, this thing should work. It's subscribed to the topic in topic and print out any messages. It assumes that received payloads are strings and are not binary. If the first character of in topic is a 1, it turns on your ESP LED on the ESP8266, and if it's a 0, it turns it off. It'll reconnect to the server if the connection is lost using a blocking reconnect. See MQT reconnect non-blocking, for example, how to do it another way, and add the following package. In other words, it's telling us here how to go grab the ESP8266 to the Arduino interface for the boards. On Tools Board Manager, select the board for the ESP8266. And so we have here SSID. Again, that's our bakery and our bakery password. The broker, again, is going to that's the HiveMQ broker. And then the first thing that we go and run is our setup. So we need to go down and look for setup, wherever that happens to be. There's setup. So what setup does is it says initialize the LED as an output, connect at 115.2, then it calls setup Wi-Fi. I think I saw setup Wi-Fi up here. Okay, setup Wi-Fi. Says connecting to, so if I look at the serial monitor at 115.2, it's going to say connecting to, and then prints my SSID, so like bakery 204. It sets it up into station mode, so I'm acting like I'm a device and not an access point, not like acting like a router. We have the ability to connect it up to an access point and an actual be a router. And oftentimes you'll find different devices that in order to connect up to your network, you first have to connect to the device, and then like with your phone or with a laptop, and then put in search for your Wi-Fi and then say connect and give a password and all that. The ESP8266 has the ability to do that, have that little web server there, just with enough information to allow you to connect it, and then from then on it will connect up to your local network. If it tries to connect and it doesn't get Wi-Fi, it can go over and do that. That's part of the software, and some examples will have that kind of ability. In this mode, we're just setting up as a station, so I needed to have my network and the password put in. And then what it does is it says, okay, until you're connected, wait a half a second and print a dot. So you'll see connecting to bakery 204, and then it's going to have a bunch of dots until it finally connects. And then it's going to say Wi-Fi connected. It's got a random number. And then it says, hey, what's your local IP? So you've got that. And then we're back down to that was all still part of setup. That was setup Wi-Fi. And then once the Wi-Fi is connected, it looks at the broker's address at port 1883, and it says set up the server for that. Point to that broker, that MQTT broker, which is that Hive MQ. And then it says set up a callback. When we do things over the internet, things don't happen right away. And so my program will still run. And then whenever I get a response back, and for instance, on MQTT, I will go and run a callback. So for instance, when I connect up to the MQTT broker and I say I'm subscribing to various topics, the broker keeps track of all of that. And if any time, maybe a week or a month or a year from now, somebody subscribes to that topic, it will say, am I still subscribed? And if so, it forwards that out to me. Okay, and so as soon as it does that, as soon as it goes into my ESP8266, the callback function is called. And so we'll have a look at what happens. So that's one of the last things in setup is this callback function gets called. And so up here, I have a callback and it just says, hey, there's some sort of payload and it'll say the length. It'll print out message arrived. It'll say what the topic is, and then it'll print out the payload of whatever the message is. Okay. If the first character in the message being sent out was an ASCII 1, it turns on the LED. If it wasn't, it turns off the LED. Or if it was a 0, it turns off the LED, more particular. Okay, and then we go to loop. And then it says if client is not connected, call reconnect. And hopefully we were connected. And then it calls client.loop, which goes and checks all of these different things. But it says reconnect. Well, reconnect here, it says, if we lost connection, then print out attempting to reconnect, and then have a client ID, and then it has a random client ID. I'm not, every time I connect to the Hive MQ, it's just giving me just a random ID. It's not saying I'm a certain client. I'm always a different client that gets on there. I don't need to say that I'm the same one or anything for that. If you had your own subscribed and they were giving you a certain client access, then you would not have random, you would have a very specific client ID. And then it says once it connects again, it'll say, hey, publish an announcement. So to the topic, out topic, it's going to say hello world. So if I said ESET260 out Mel hello world and I was subscribed to ESET260, it would say hello world every time it reconnected, and then it would give me another message. And then I may have dropped subscriptions here. As soon as I log in, I'll say, hey, by the way, subscribe to in topic. Well, I don't want it to be that. I wanted to subscribe to in Mel for that. And then if it doesn't work, then wait 5 seconds and try again. And it's always good to wait. Now, depending on the place that you go and connect to, they might want you to wait a lot longer. There's a place called ThingSpeak. I'll show you ThingSpeak in a couple of minutes that has a slightly different way of doing things, but they want you to wait at least 15 seconds. I was doing some things on Samsung Spark websites, and they wanted you not to connect more than once every 15 minutes. And so you have to look at that, because if you don't abide by those terms, they can say that you're spamming them in something and then just block you. So you don't want that. So you want to see how often can you go and communicate. So if I needed to reconnect, I call that reconnect loop. Otherwise, I'm just going to run in our loop in here, and it checks to make sure I'm still connected. And then it says, hey, if the message now minus the last message was greater than 2 seconds, then update to, so the time is now, and then send out hello world to out topic. So it says publish message out topic hello world, and that's where I got those hello world scrolling by. Okay, so your what you had to do then over in the lab was subscribe to out your first name and demo sending and receiving of MQTT messages to the D2L assignments folder by the start of lab 12. Your demo needs to show you turning on and off your blue LED. So I wanted to see that you could connect to it and then send a message back to your device and turn it on and off your blue LED. And it's just showing hello world here, just scrolling by to, in this case, ESET 260 outmel. So it's a way of our ESP8266 device just by itself being able to go and connect up. Now, let's see what else I got here. Now, I wanted to, one of the other, so this is MQTT, and again, nice, very efficient, very battery friendly. I wanted to also look at another place called ThingSpeak. And there's some examples. If you look Arduino or ESP8266 ThingSpeak, I have in the past done labs with ThingSpeak. We're not going to do labs this time with it, but I just wanted to show it there. So just like we did PubSub that you searched for, you can search for ThingSpeak and see ThingSpeak stuff. ESP8266 works well with it. ThingSpeak was bought out by, I believe, the MATLAB people. And so there's public channels. You have up to 8 fields that you can send information to. And so you can then use some of the MATLAB different features to be able to do things with it. You can graph things. I wanted to just show you a couple of channels I have. This channel, I've since sold the fifth wheel, but this channel since 2014, I had an ESP8266 sitting with a temperature and humidity monitor in my fifth wheel, and every minute, and you don't need to do this for temperature and humidity, like 10 minutes, half hour is fine, but just to showcase what was going on here, I wanted to do it every minute. This has been running, even though the fifth wheel's gone, now it's just in my room in the back, still plugged in and reading fifth wheel temperatures and data and all of that kind of stuff. But this thing has been running since 2014 from ThingSpeak, as long as I can access the... So 7 years ago, last entry was about a minute ago, and I have 5.1 million entries of temperature, humidity, battery level. And so so there it's showing me that it's all kind of in one here. So my battery level is sitting at 3.3 volts. My temperature was 19 degrees. There's another temperature. I have a DS1820, which is a more accurate temperature sensor, but it's just temperature by itself. It's a one-wire Dallas Semiconductor one-wire temperature sensor. And then there's also the DHT11s or DHT22s. You might have them in your Kuman kit. I'm not sure. They're like they look like a little blue unit with little cross hatches on it. That's called a DHT11. So in ESP8266, there's a lot of examples using temperature humidity on DHT11s. So I've just modified one of those and stuck the data up here. So this is my, it's saying my humidity is 37% in the room it's in. And again, I need to zoom in on this, you know, because back here was 2014 and over here is November 14th, 2021. So I have to change my scale. But you know, 5.1 million data entries, and there's the latest showing me just right now. There another data point just popped up, you know, showing 157 and 11 seconds. It just sent data and said it was 19 degrees over there. It's an ESP8266. It's a little lithium ion cell, a DHT11, a DHT22, and that's it over for that one. You could easily put a light dependent resistor, see daytime, nighttime, do all of those kind of things. Going on here, if I look at the channel settings, so I have my channel ID, and then it says fifth wheel, and then I have temperature 1, 2, and 3. I've got battery, all of this kind of thing. I also have something in the description. You can actually go in and read the description. And what I was doing was using those as set points to decide when to turn on a Wi-Fi controlled plug to turn on and off a heater in the fifth wheel. Okay, so that's all just done using this. And so I have 8 fields that I can put data up to, and it's free for you to use, has been for years. So it's kind of neat. One of the other channels I used was, oh, not over there. Let's go in there. So this one, what I was using is on a Raspberry Pi, every time my IP changed, I would just post like it was just data to the ThingSpeak channel to update what my new IP address is. So without having to use other DHCP servers or dynamic DNS servers or what have you, it would set that up. So that's kind of ThingSpeak. It's kind of neat in that, again, you search our ESP8266 ThingSpeak, or you search Arduino ThingSpeak, it's going to show you that. We, in the past, have done a lab. We're kind of running out of time for doing some of that, so I didn't give you a ThingSpeak one this time. Some of the other things I wanted to talk about a little in this as well are some of the other ways that we can connect. And we looked at connecting with, let me just plug this in. We looked at connecting with AT command sets and the modem. And so I just wanted to show you some of the other units. This is a little Quectel modem, and it responds to AT command sets, but it's got a SIM in it. And so it's for cellular. In fact, it's for LTE. And so you could have this is sitting on a little Arduino interface, but it's using the AT commands like you did, AT plus reset. It has a few other AT commands to be able to do connect up to some of the cellular, ask for what your phone number is. You can send SMS messages. You can just send data just like it's connecting up to Wi-Fi. These little modules are anywhere from probably this module with this little breakout board's about $50. These things are probably around 38 if you were to put it into a device and not plug it into one of the Arduino Shield interfaces. The project group, not this year, but the last year's project group, they had modules like this in a little waterproof case, and we're using the cellular network to track the rowboats down in the gorge and stuff, all the different kayaks and things that were the rowing club down there had out, and also had capsize sensors, and so would able to notify the employees back at the base what was going on with all the different boats and where exactly they were on Google Maps, and it went and plotted it. You use something like this. Okay. Now, one of the things with that, they had a sponsorship with TELUS. They gave them some SIMs, but you can. There's all sorts of companies that have different SIMs, and just pointing out one of them, in fact, the one that's in there is from a company called Hologram. They'll give you a SIM because they want you to start playing with this stuff for free, 1 megabyte a month. And so when you look, you kind of look at a message. You know, we said when we sent messages, you looked at the UDP messages, and they, you know, you're looking at, 64 bytes kind of thing on a UDP message. If we send to MQTT, you're probably, you've got TCP, so there's a bit more handshaking. But let's say you're 500 bytes a message sort of thing, and you have 1 meg a month. So you have to do the math to see how many messages you could send. If you could pack your temperature, humidity, or capsize information, or what have you. So they'll give you one card. After that, they charge you a few bucks a month for a card. And there's different ones you can get. One will charge you, I think one version of this will charge you 60 cents a month for the year, and then so much a message, or if you have more messages, but the thing is, it can You definitely wouldn't stream on it if you're looking at how much it costs per megabyte. But if you're sending small messages and it's the upfront costs, you know, uh, you can, like I say, you can get one SIM card. They'll just send it to you for, I think it costs you probably $5 for mailing it or whatever to send it to you, and you can put those kind of things in. The other thing about these kind of cellular, and it's not just hologram, a number of companies have it, but if I was to put this little unit in a package, or I was tracking some container or something, they are automatically connect to networks in 150 countries. It will they've got the whole back end worked out. You don't need to go and say, oh, I need a subscription to Bell or Telus or whatever. It'll connect up to networks in 150 countries. So you could put something in a device and track where it goes, and as long as it gets cellular somewhere, it's chances are it's going to connect. So that's kind of interesting. Again, you do the same thing that you did in the last stuff with me with going AT plus reset, do the TCP command. The TCP command that this uses is pretty much identical, okay, to setting up a TCP connection. So the reason I talk about this kind of thing is just to look at, projects are going to come up soon. This time next year, you guys are in project, right? So that's one of the things that we need to start talking about.